in continuity and differentiability is f of x is equals to mod x by x if x not equals to 0, 0 if x is equals to 0. So find all points of discontinuity. Find all points of discontinuity of f. So for this function we find the discontinuity points. So before going to find the discontinuity, we check continuity of this function. So we will first check the continuity of the function. So we check continuity for different values of x. The different values are, here they gave x not equals to 0. One more is x is equals to 0. X not equals to 0 means either less or greater. So I will take when x is equals to 0, first case, and second case when x greater than 0, third case when x less than 0. For these three cases we check continuity. If it is not continuous, then discontinuous it is. So go for the first case, case 1. When x is equals to 0, I told already when x is equals to one value, the formula is LHL is equals to RHL is equals to f of 0. Here the formula for LHL is left hand limit for 0, that is limit x tends to left hand value for 0 is 0 minus f of x, that equals to limit 0 tends to 0 minus will become from 0. So h tends to 0. F of this x is replaced by 0 minus h. 0 minus h. Now we will write that value. Limit h tends to 0. F of 0 minus h is f of minus h. Now write the function in this. What is the given function? The given function is mod x by x and 0. For this case, when x 0 minus means when x is 0 minus means not equals to 0. 0 minus means it is not equals to 0. So at that time the function is mod x by x. The function is mod x by x. So and here we remove the mod. Limit. So in the x place we have h. So I will write mod h by mod minus h by minus h. So mod minus h by minus h. Now remove the mod. In the modulus, if we get negative also, will become positive. So mod h by minus h. Cancel h. It is minus 1. So all LHL we get minus 1. And next go for RHL. RHL is equals to right hand limit of 0. Limit x tends to 0 plus f of x. Now I will start from 0. So limit h tends to 0, f of the 0 plus will become here x is replaced by 0 plus h. Now write the function. H tends to 0, f of plus h, limit h tends to 0, f of h is when the function is more than 0. 0 plus means when the function is more than 0. More than 0 means here we have two cases. One is equal, another one is not equal. Not equal means either lesser or more than. So here we are taking more than 0. So at that time the function is modulus x by x. Function is modulus x means what here? H. Modulus h by h. Now limit h tends to 0. Mod h is nothing but h only. Cancel this and we get 1. If you observe, LHL we got minus 1, RHL we got plus 1. So LHL not equals to RHL. When both are not equals, then F is not continuous, means discontinuous. F is not continuous. Means it is discontinuous. Means F is discontinuous. So this x is equal to 0 is discontinuity point. We got 1 point as discontinuity. Next go for the second case. Case 2. At x greater than x is greater than 0 means the function is mod x by x. X greater than 0. Limit x tends to 0, f of x is equals to limit x tends to 0 greater than 0, mod x by x. For greater than 0, mod will become positive. So limit x tends to 0, this mod x will become plus x. Why? Because as x greater than 0, it is more than 0. That's why mod will be, it is equals to 1. So this is constant. 1 means what? It is constant. Then f is continuous for x greater than 0. So when this is constant, f is continuous for x greater than 0. Now go for the case 3. Case 3. What is the case 3? Case 3 is at x less than 0. This is case 3. So when it is less than 0, the function is mod x by x. So it is, we apply, actually this one mod x by x for less than 0, it will become minus x by x. Cancel this, it will get minus 1. So this is constant. It is constant. Therefore f is continuous for x less than 0. So final conclusion, f is continuous for all real numbers except 0. Therefore f is continuous for x belongs to R except 0 case. Next is 8th question. Question number 8. Find discontinuity of all points of this function. The function is 8th over. Now 9th question. F of x is equals to x by mod x if x less than 0, minus 1 if x greater than or equals to 0. Now find discontinuity of all points. Find discontinuity. So for this, first we check continuity. So first we check continuity for different values of x. We check continuity for different values of x. So the different values are, the first case when x less than 0, second case when x is equals to 0, and third case when x greater than 0. So I will select the first case, case 1. When x less than 0. When x less than 0, what is the function? That is x by mod x. So f of x is equals to x by mod x. So it is less than 0. Less than 0 means negative. So I want to remove this modulus x by minus x, then minus 1. So this is constant. Therefore f is continuous. F is continuous. Next, the next case is x is equal to 0 case. Case 2. when x is equals to 0. First write the formula. What is the formula? When it equals to, then LHL is equals to RHL is equals to f of 0. How can we write a left hand limit of 0? That is, limit x tends to 0 minus f of x. Now I will start this 0 minus from the 0. So now I replace x by h. Limit h tends to 0, then f of 0 minus h. Now 0 minus, what is the function at the time? 0 minus means less than of 0. Less than of 0 is x by mod x. So this is the function x by mod x. But here x is minus h by mod minus h. Now I will write this modulus of negative value will become positive, minus h by plus h. So this value is minus 1. Next, RHL. In this only we will find RHL, that equals to limit x tends to 0 plus, means right hand value. So 0 plus f of x, that equals to limit h tends to 0 f of 0 plus h. Limit h tends to 0. Now f of 0 plus more than 0. The function when it is more than 0, the function is minus 1. So when it is more than 0, it is minus 1. The answer is minus 1. Next, find f of 0. So I found LHL, RHL, now f of 0. F of 0 is equals to, when it is equals to 0, see the question, when it is equals to 0, the function is minus 1. So it is minus 1. If we see LHL we got minus 1, RHL we got minus 1, and f of 0 also we got minus 1. Therefore LHL is equals to, RHL is equals to f of 0. Hence f is continuous for x belongs to, for x is equals to 0. Next, last case, when x greater than 0. The last case is x greater than 0. Case 3, when x greater than 0, then function is, when it is greater than 0, what is the function? Just we check the question. It is greater than 0, the function is minus 1. So it is constant. This is constant. Therefore f is continuous for x greater than 0. So finally, hence f is continuous for all values of real numbers. F is continuous for all values of real numbers. So this is the case. In this question we didn't get discontinuity points. So in every case we got continuity points only. There is no discontinuity in this question. Thank you. I hope you are understanding. If you are getting any doubts, please comment.